Welcome back! Now we're going to talk about carbohydrates. This is our second lecture of our little set of cell makeup, and we're going to talk about carbohydrates because carbohydrates are super duper interesting. So, as we may already know, carbohydrates are kind of the main energy source for our cells, and later on when we go through the function of mitochondria, we'll learn about how exactly one gets energy out of carbohydrates and indeed glucose. But for now, we'll just learn about the basic structure of our favorite carbohydrate, glucose. We'll learn a little bit about polysaccharides. So saccharides is just the sciencey word for sugar. So polysaccharides, monosaccharides, and disaccharides. And we'll talk about the 1,4-glycosidic linkage, which is how we link together our di and polysaccharides. And indeed, we'll talk a little bit about the macroscopic structure of these branched and non-branched polysaccharides and what that means. So let's get into it. Because I have this nice little summary here, so you have everything that I'm going to talk about. Right, so what are saccharides? What are polysaccharides? So as I just noted, there's glucose, and when you have glucose come together with another glucose, you get maltose, which is like caramel. And that comes together in a 1,4-glycosidic linkage. Now, I'm going to talk in detail about the structure of our glucose, but what I mean by a 1,4-glycosidic linkage is this here, or here, is our number one carbon, and it links with a number 4. And it does a glycosidic linkage, which is a dehydration reaction, which means that we get this OH with this hydrogen, and they spit out a little H2O, and they make a linked disaccharide. Now that can go on and on and on, and that can make a polysaccharide. Now, based on what I've written on the whiteboard here, what do you suppose a polysaccharide of glucose could be called? Starch. It is starch, which we've heard plenty about in the form of potatoes, etc. But within our polysaccharides, there are branched and non-branched, and we're going to talk a little about what that means. So a non-branched polysaccharide can kind of stack very nicely on top of itself. It's one linear line, so there's less kind of breakdown machinery that you can get on it, as compared to a branched polysaccharide, which is a bit more spaced out. And the branches allow you to get a bit more breakdown machinery on it, your molecular machinery. And so, what that means is, our branched starches and our branched polysaccharides are a bit faster to break down. And this speaks to our kind of GI numbers of food, which I won't go into in any detail at all, except to say that things which are simple break down like that, and things which are not simple break down like that. And so if you have singular, long chains of polysaccharides, it's going to break down more slowly than a polysaccharide which is branched, right? Non-branched, slow, branched, fast. Remember that. Need to stop kicking the tripod. Now, I talked about the glycosidic linkage, and I talked about these two linkages. So you're going to get your straight linkages are going to be 1,4 because it's going to be binding this guy to that guy, and it's going to look nice and flat, right? Nice and flat. But you can also do 1,6 glycosidic linkages, and number 6 is way up here. Way up here. So he's like way over here, right? And of course, if you have both a 1,4 and a 1,6, or indeed a number of 1,6s, it kind of winds up a bit all over the shop. And so you can have both of these kinds of bonds on one polysaccharide, and you end up with a branched chain, which leads to our branched and non-branched mechanics. So that's very interesting. And we have our dimers and we have our glycosidic linkage, which I mentioned. And of course, the glycosidic linkage is just a dehydration reaction. Now I'm going to talk a little bit about the structure of glucose. Now, I would strongly encourage you to write down the structure of glucose in its entirety in both the linear and non-linear forms, but it is up to you. Now, the linear form of glucose is what we find in solid format, and the circular form is what we find in aqueous solutions. And the important thing to note about these two configurations is that you have the fifth carbon linking to the first carbon. That's a 1. Right, the fifth carbon linking to the first carbon via, you guessed it, a dehydration reaction. Okay, so this 5 goes around and he connects to this C here via a hydrogen-oxygen bond. It's a hydrogen bond, it's not a fucking glycosidic linkage, I lied. And so this, I don't actually know how that works. Anyway, it bonds together in a ring when it's in aqueous solution, and then we find this entire little structure. And so, important to note that you've kind of got this flyaway guy here, number 6, which sticks off the 5th one when it's in the round formation, when it's in the hexagonal configuration. And there are these 2 configurations of glucose. And so you get this 5th guy doing this, right? And they make that circle. So it ends up with this 5th guy attaching to that carbon in some way. Whatever. That's the way that we get glucose in its round and straight formats. Thanks, guys.